What I have here is a bit of a different thing for me. These are a pair of connecting rods out of a Coventry Victor engine. A friend of mine has been having a bit of an ordeal with these, trying to get them re-babbeted. The babbitt is kind of failing here. This is the original one here. Having a hard time getting this focus. Anyway, you can see here where the babbitt is failing. There's not really a lot of babbitt on these rods. Of course, when you get a modern engine with insert bearings, the babbitt is only a few thousandths of an inch thick. That's why when you're rebuilding an engine, you look and you see if you can see the copper sub-base coming through the babbitt. This is one, he took it to a fellow who was good at doing Model T rods, but the problem is with a Model T rod and a Model T blocks, they're babbitted as well, but they're very specific jigs and fixtures for doing this, and you can't just take something like this where there's probably only 15 thousandths of an inch of babbitt on here, and the thing, and there's not really enough. There's not a lot of room for error. I'm debating whether or not to machine these out a little bit bigger, so I do have more margin for error. But I think the key with a successful babbitt job is having a consistent thickness. You can't have a thick spot and a thin spot. I know on my own Model T there was a NASCAR guy who, a really good machinist, very fussy guy, and he had the correct line boring jigs for doing the block, but I know before he even poured the babbitt, he line bored the block to make sure that it was going to be concentric around the crankshaft and a perfectly uniform thickness of babbitt. I'm not sure what I'm going to do with that yet, but I just thought I'd show this to show what I'm starting with, and later on I've got some videos I'm putting together of the fixtures I'm making. The rod bolt holes here, and initially when I started out, these were about 1/8 of an inch different. It's amazing that the thing actually functioned. That probably might have been what took the babbitt out in the beginning. So what I've done is I'm just using taking the rod back and forth out of the fixture, putting it into a vise with a wrench on it and giving it a bit of a twist. And here I'm verifying the measurement. Here I have between my datum surface here and the pin. I've got it pretty close now. It's down to about 10 thou. Close. I think I'm going to give it one more tweak, and that should be close enough, or I should be getting it fairly close to getting it close enough to do the thing. The other thing I did with this fixture is I just put a little notch in here, because there are 2 rods I have to do. This little notch here will make it possible for me to repeatedly index it in my milling machine. I'm going to use a boring bar to bore out the babbitt when I do pour it. So that's the fixture, and it's not uncommon for most engines for somehow this axis to be different from this axis, but for a smooth running engine with minimal friction, I think it's very important that these 2 axes are parallel. So that's why I'm spending a bit of time tweaking this. This angle here might better illustrate what I'm dealing with here. I'm just going to move the foot of my digital caliper down here. Here I have 0.793 from this pin to the datum surface. This one here, it is 0.802. So it means I have to take the thing out and just give it a little bit of a twist this way at the big end. So I'm getting pretty close. These are my two saddle blocks. I roughed these out of aluminum on my CNC router because I wanted the locations to be fairly precise. I've made these holes oval so there is a bit of an adjustment here. This will be one for the other side. I'll just tilt this. You can see that the rod is not symmetrical, it's different. So I'm going to need to, when I go to face the back side, I'm going to have to flip the rod over, and then these bolts are going to be in a different position. The ones that support the big end of the rod. So this one is machined a little bit shallower, and it's a very snug fit on here, as is this one. This one here I will use on the other side when I flip the rod over. When I flip the rod over, it's going to sit in a different position. Everything is referenced from the wrist pin. So here, this one is a little bit lower, but it will go on. So now what I have to do is make a precise measurement from these pins now that the rod is straight after many trips back and forth to the vise with a wrench. I'll get a height from this, subtract it, the diameter of these pins, and precisely drill 2 holes in the bottom end of this block, which will receive 2 bolts, which will go through this block and through the holes in the rod that will keep the cap and the rod together securely while I'm machining the babbitt. And then when I flip the rod over, I have this one with a little shallower notch, which is precise. This is 0.1. I think the other one is 0.25 offset. You can see the difference there. So it'll have different set of holes in this one to receive the bolts when it's flipped over. So that's why this is a little bit more than a 5-minute job. I did a CAD drawing of what I'm trying to achieve here. Now I'm just getting down to the measurements. I've measured the height of the pins and the width, and I've done all my scratch pad arithmetic on the drawing there. Just so I don't mess this up, I have a center position on my DRO on the mill. So here I'm going to offset the hole 0.6832 this way, and from my reference surface I'm going to go up 0.351. So now I'm going to flip the rod over and just do the calculations and put some notes on the other block, and then I'll get to machining the holes to receive these pins on the other side. Machining with the pins for the rod in the second position upside down. The one thing I have left to do is I just have to drill and tap a couple of holes here so this can be clamped in position. I think while I've got the thing in the mill, I might take my boring head and just pocket out below the rod here a bit of clearance, because I know when I make the babbitt I'm planning on putting some cheeks on it, so I'm going to need a bit of clearance at the bottom here. This position here, it's pretty well down, but I think it wouldn't hurt to have maybe about a 0.10 clearance on the bottom. I have ordered some cap screws or bolts. I'll have to see how precise they are. This whole setup is very precise and repeatable, so you can get both rods done the same. When I set this up in the mill, I'll be able to accurately keep the distance between the wrist pin and the big end here. What I have to do now is locate the 0, position. I'll set this on my DRO to the center of this pin, which will be the center of the wrist pin. From there, all of my reference measurements for machining the big end will be down at the end. That way I can make sure the stroke on both rods is the same to within the thousandths of an inch. So I've got this cool little toy here. It's a centering indicator, which will allow me to center it about the DRO. So within about a thou, I've actually been playing with this before. First time I've used this. It's a very useful tool. So I'm centered on the pin there. Now what I'm going to do is I'm going to set the 0, on my DRO. And see what I've done when I made this fixture is I made a little notch here, which I've just tapped it so it's right on the edge of the vise. The vise isn't going to move. So now I know 0 on this pin here, and this is where I'm going to be machining the babbitt. This whole process is kind of like watching grass grow. Now that I've located the wrist pin center on the jig here, I've used the coaxial indicator to find the center of the rod before I start taking the babbitt out. This is probably about the closest representation to the distance here. So I'm going to leave the 0 position centered on the wrist pin. And here I've just marked it on my jig here. I know the offset is going to be 4.690 to the center of the big end. So now I can remove the babbitt, and I might just see, I'll probably put the thing back into the jig here and just run a indicator around and see how much offset I have or how much clearance I have for the babbitt. If it's not what I think is enough, I think I might just run the boring bar through the casting before I tin them. I've got the center of where the big end is supposed to be from the rod that was untouched. I centered the pin and then did the offset, so I know the offset is supposed to be 4.69 inches. So I put my jig back in the milling machine. I haven't touched the readings on the DRO. And this rod has been kind of rebabbited but messed up. So what I'm going to do on both of these, actually, I'm going to put them back in here and just run the boring bar through here to clean out the babbitt. And I'm also going to make sure that there's a consistent distance from the center to the base metal. I can tell as I'm going down here that the old babbitt was not bored in a parallel axis to the wrist pin because it's coming off in different amounts. One problem with the boring bar, though, is you can only go very slowly, even though I'm using a carbide cutter. You can only do a few thousandths of an inch at a time. The other rod I did in the lathe, and it's a little easier to machine on the lathe, but I think this is more accurate. So I'm just going to give it another 5 thou. Take one more cut. Seem to be getting a nice consistent cut all the way around now. I've got the second rod positioned in the mill in my fixture here. I have the distance marked here from the wrist pin to the center of the big end is 4.690. So I'm just going to machine out the babbitt, and after I've done that, I'll be tinning the rods. So I've got the connecting rods in my sandblast cabinet here. or media blasting. What I'm going to do is I'm just going to clean up the rods really well, so the tinning will be successful, I hope. So I've got a bit of this Tin Easy Flux here, and looking at it, it's going to be a little hard to get the powder to stick here. I actually Googled the directions, and it says it can be mixed with Johnson's tinning liquid or water. So I think I'm going to use water, since I have that here and I don't have to worry about customs brokerage on that yet. I'm just going to make a little bit of a paste, and then I think the idea is when I hit it with a torch, the water will evaporate and the tin particles in this compound here will tin the rod. So I've added a couple of drops of water to this, and I've stirred this stuff into a paste. I'm going to apply it to the inside of the rod here. I'll also do the cheeks here. I got the torch going. I'll see how this works out. One thing I did forget was I'm going to go over it with a wire brush when I'm done. Just grab that. Okay, I've tinned the rods and the caps so the babbitt's going to stick where I want it. Now I don't want it to stick to the molds, so the molds are going to be heated to about 450 degrees when I pour the babbit. So there is a good chance it is going to stick, but one of the traditional methods of preventing babbit from sticking is called smoking. I guess normally you'd do that with an acetylene torch, but I don't have acetylene. I use propane and oxygen. It's a lot less soot in the shop here. I've got my pieces here. I'm going to just get a bit of soot on here to keep everything from sticking. This is a clean burning candle. I had a candle, I threw it out for the spring tour when I was cleaning up. It was a really sooty candle. That's what I could have used right now. This one's going to take a while to get some soot. Next thing I have to do, I have the one of the caps in the mold here. I've got it the cheeks pieces on here. They're up fairly tight. But I'm also going to add some of this damming compound to keep the babbit from running out, because everything's going to be kind of hot and liquid. So I've got this stuff called Cap Hot Dam Putty. So I'm going to take a little bit of this stuff. It's probably asbestos or something carcinogenic. It seems like all the good stuff gives you cancer. I'm going to make a couple of little strings, and I'll just seal this all up. It'll be ready for the pour. I'm getting ready to pour the babbit. This is John actually found a guy who had machined a bunch of babbit. These are all of the shavings from the babbit. So I'm going to use these. I also have some virgin babbit. This is number 2 babbit, which is a high tin content rather than zinc. Zinc is used in like low RPM applications like steam engines. That's number 1 babbit. This is number 2 babbit. It's supposed to be made for high-speed applications like an internal combustion engine. What I'm melting it on here is a little stove I've got. You can see there's, because it's machined, there's probably a lot of crap here. So I've got one of Rhonda's good kitchen spoons here. Just taking this shitty stuff off the top. This is called dross. I think ideally the temperature is supposed to be about 850 degrees for pouring it. Also, the mold should be about 400. I have the mold here in the vise. I've got some of the damming putty around there. Hopefully that'll stop any leaks. The idea is I've got this little funnel here. What I'm going to do when I pour it is, after it solidifies a bit, I will just give this little tweak with a wrench, and then this part will come out, hopefully, leaving a sprue inside which I can cut off. So I'm going to put this back in. I've machined a little bit of a funnel in there. I've also got a drill bit handy. After I pour it, when it's cold, I can just get the excess out of the top here to make it easy to separate the mold. I also have this digital thermometer. So I'm just going to check the temperature here of the Babbitt. It's still 420, depending on where I put it. Still has a ways to go. So I'm going to let that heat up for a bit. I might add a little bit more. While the Babbitt is heating up, I'm going to got my torch out here. I'm going to heat up the mold, try and get it all consistently warmed up. I think ideally the mold should be 450 degrees. And the Babbitt 800 to 850 degrees. So we'll see how this all works out here. Surprised I haven't set the smoke alarm off yet. Taking a little while to heat this Babbitt up. I'm just checking the temperature here. About 570. It's supposed to be 800, so it's going to probably be another 10 minutes. I think I heated the mold too quickly. It's cooling down now. That's about 140, so I think I'll wait till the Babbitt is about 170 or about 700. Then I'll take the torch to the mold again and heat that up. Seems to be a little stuck here. Might need to do a little bit of a modification on this part. Okay, I'm going to take the bolts out here and see what kind of a mess I made, or what kind of a success I've achieved. Smoked this a bit more, so now I've got the two cheeks here. See, my Babbitt damming compound is pretty well baked here. Well, it looks promising. I've got a nice cheek there. Let's see what the other side looks like. And hopefully I've tinned it or smoked the mold enough that on here I see what's happened. I've filled the slots here, so I guess on the next one I'm going to have to put a bit more damming compound in these holes here. This has worked well because it's allowed the Babbitt to vent up. Looks like I've got a nice full pour in the cap, lots of room for machining there. It's going to take a little bit to get this off. I had the 4 tabs that were locking it into the mold mechanically. I took it over to the vise and just tapped it out. One of the little tabs was there. I think maybe that is a good thing, having this ventilation, because it looks like it's made a nice full pour into the cap here. I've got nice cheeks on both sides to machine the thrust faces off. Still have to figure out how I'm going to machine this radius here in the inside of the rod with a boring bar, but for now I'm pretty happy with the way this has turned out. I guess I've got 3 more to go and then we'll continue on with the machining. I've got the Babbitt poured. Got nice cheeks on this one. This is a little stub that's left off where I used a wrench on the on my pouring spigot to break the Babbitt. I've just run them across some emery paper on the table saw flat surface to clean up the sides here. Noticed here these things are indexed, they're marked. This is number 2 rod, so what I'm going to do now is I'm going to put them back in my fixture. I'm going to put the big side down on the wrist pin side. Rather than using the pins like I had previously thought, I've got these are a little more precisely made hex head cap screws. They're 2.5 inches long. That'll allow me to put a nut on the end. What I did have to do here is I did grind a flat on the one, because it does have a little notch where the original connecting rod bolts are indexed against the side of the rod. Just going to tighten this back into the jig here. Just going to tighten this back into the jig here. I've got the big end of the rod, or the cap, bolted together, the 2 halves of the rod. This is number 2 rod. I've got it facing up. I'm just going to, I left lots of meat on the Babbitt. I think I'm going to wind up with about 20 thou. I've probably got 1/8 of an inch thickness there beyond the parent metal. What I'm going to do now is I'm going to bore it. A light bore to clean up the entire side. I'll give it a measurement, get a reference from where I'm coming from, and then I will mic the crank, which has been ground to make sure it's perfectly round. Usually a crankshaft, if it's out of round and you don't get it ground and round it off, it'll eat up the bearings pretty quickly. So this is the first cut. I'm just going to use the boring head, go through this. I'm not sure exactly how I'm going to face it. I'll probably have to grind a different cutter and possibly make one with a radius here to do the radius on the outside of the Babbitt, but I'm just going to bore that for now. Just looking at the finish here, I don't see any big air bubbles or anything in there, so far we're better than what it was from the factory. Now I'm just going to have to mic this and figure out how much further I have to go from here. I just finished miking the crank. Looks like it's been ground down to 0.980, so I'm going to point that. Just write that on the vise there so I don't forget. Just going to mic the inside of this now and find out where I am. I'll probably redo this in a little bit when I get closer. I just need to know how far I am now. So I'm at 852 now, 853 right now. So 0.852, I have to go to 0.980. So that means I'm going to have to take out, if I take out 25 thou, or move my boring head out that much. There's 10, 20, 25. So that should take me to 0.980. So I'm going to cut that. I'm going to remeasure it probably a few times as I get closer. This next cut should take me to 0.950. Which will give me another 30 thou. I might do that in another 2 passes. Okay, I've taken the final pass. I'm at exactly 0.980, which is the same size as the rod. Conventional wisdom as far as the clearance goes is anywhere between 1 thou to 3 thou for a rod. I am going to use a product called Time Saver on this and lap in the bearings to the crank. It basically burnishes the babbitt and does a pretty nice job. I think that will work with the clearance I've got. The next thing I have to do is face the cheek here. These are wider than the clearance between the crankshaft. So what I'm going to do is I've got this other boring bar which will fit in here. But when I look at this, these are all ground with a bit of an angle. So what I'm going to do is I'm going to grind that off until it is perfectly square. Then I can do the face, and while I'm at it, I'm going to take it a little bit out, and I'll put the radius in this, and that way I can do the internal radius in the thing as well. Let me get it to focus here. This is the other cutter I've ground. It's got a little bit of a radius in there, and it's exactly right angles to the chucking end of the boring bar. So what I'm going to do now is I'm going to put this in here and face the cheeks. I'll flip it over and mic it and get a precise measurement for the other side. What I'm doing now is I have the rod machined right to the size. I've faced the cheeks. There's a bit of clearance here side to side. I've put a slight radius on the inside. Now what I want to do is I want to seat these bearings onto the crank. For that I'm using this it's a product called Time Saver. It's a very fine abrasive compound. It comes in a kind of a green powder, You mix that with a bit of water or oil and into a paste, which I've got here. I'm going to put this on the crank and basically just work the Babbitt around on the freshly ground crank. One thing I am going to be careful about is, because I'm using an abrasive, I want to make sure I get it all off. I'm going to put a bit of, I think, plasticine in this hole. This is an oil hole. The idea is the oil pump basically right at the back of the engine, or behind the flywheel, it pressurizes water or oil through this main bearing. It's drilled internally diagonally up to here. It's also drilled this way, so there is a passage that goes from here up to here, and it shoots oil into the connecting rod. So I want to make sure I don't have any abrasive that's going to be left in that hole. So I'm going to fill it with plasticine. Then when I'm finished the whole operation, I can drill it out and maybe even flush it with a bit of compressed air and a bit of solvent to make sure I get everything out of there. I've got the rod bolts tightened up. Got the time saver on the crank throw here. I know some guys, when they do a Model T engine, it's so tight that you have to put the car in gear and tow it to start it. I've heard some people say if you don't make them that tight within the first season, you'll be taking shims out of the rod cap. I'm not sure about that. I just know that normally, if this was a insert bearing engine, I'd probably be looking for about 1.5 thou clearance on the big end here. But it's rotating fairly freely. I'm going to just snug up the last little bit on the rod. A little bit more resistance there. And I'll just keep doing this until it's spinning freely, but it's nice and snug right now. This is the number 2 rod. I've taken the thing apart, and I've cleaned off all of the time saver. I've also cleaned it really well with rags, brake cleaner. Just put a bit of oil on there. That's a pretty nice fit. It might be too tight still, but if it's too tight, I was just thinking you could maybe make up a 1 thou shim. That way, if it does run in, it could be taken out. The problem with one of these engines, though, is you got to take the entire engine apart to do this. On a Model T, you can drop the insert on the oil pan and access the rods and do it in your driveway in an afternoon. This is a more involved job to take this apart, so I want to make sure it's right. But I'm pretty happy with that. I'm just not sure whether it's too tight. I'm going to ask the engine rebuilder. But I think that's good for this one. I'm going to move on to the next one, and then John can get into putting his engine back together.